Let's review this worksheet named Classes, Objects, AP Style Worksheet number 2. Number 1, the answer is B, just because a regular class such as bug or turtle or string usually has a default constructor, at least if the programmer used good style. Client programs never have a default constructor. I've never seen a default constructor in a client program. Remember, a client program usually has a main method, whereas a regular class has things like default constructors, accessors, modifiers, and of course, instance field declarations. Okay, number 2, which one is the best candidate as to be a static method? Paul.
Celebrate birthday.
Excuse me?
Celebrate.
Yeah, celebrate birthday. No, that's very individual. That's something that each instance, each object in a client program would do differently. Your birthday is celebrated with balloons and cake, whereas somebody like, say, somebody named Charlie, he might just spend the day reading the Wall Street Journal, and that's his idea of celebrating. Robert.
I'm gonna go with C, get age.
No, each human would have a different age. Very individual. You are 16 and James is like 15.
Pause the video.
Sam.
Go on diet.
No, that's very individual. Some people need to go on a diet more than others. Come on, Sam. Well, what's the answer, Charlie? A. That's the only one left there. If you ask the average human, if you ask any human what the average life expectancy for humans is, well, by definition, it's the average. For men in the United States, I think right now it's like 77 or something, 76. So no matter who you ask, that's the average life expectancy. So it's the kind of method that any object could return, like somebody named Donatello or somebody named Nemo. These other things are just individual kinds of things. Now I know these are, this kind of a question is a little subjective, a little arguable, but that's the way the AP exam is sometimes. And the best answer is A. Number 3, the answer is A. That's a true fact that every object belongs to a class. I think that was the same question that we saw, or at least that answer, A, was the same correct answer to a previous worksheet. So shame on you if you got this one wrong. Does anybody have any questions why B, C, D, and E are false statements? Hey, what does an accessor method usually begin with? Not set, but get. Okay, anyway, moving on. Number 4 is C. That's false. It should be implemented by the class developer every time he or she writes a class, like a bug or a frog class or a turtle class, but it doesn't have to be. So the word must makes that false. Any questions on any of the other wrong answers? Because apparently they are all true. Number 5. Another name for a property is an instance field. I agree. But yet another name for a property is an attribute. If you read the lecture notes closely or saw enough textbooks, like I have in my time, different name for the same thing in most worlds of Java discussion. Okay, and number 6 we see here, the answer is D. Again, like a previous worksheet, you should know that the state of an object has to do with things like my health, my age, well, things like that. Whereas the behavior of an object has to do with its public methods. Behavior and state, behavior and state. Number 7, the tricky one about overloaded methods or what can't be an overloaded method. The answer is A. Again, just like on a previous worksheet, the answer was A in the same question. Now here we have a slightly different situation, I believe. You may or may not. Anyway, the fact that Roman numeral 1 has a string, comma, int, in that same order as Roman numeral 2, string, comma, int, and then of course they both have the same exact name spelled correctly, the same, that means that they both have the same signatures. And that is what the question is asking. They have the same signature, And that signature is different from Roman numeral 3 because the Roman numeral 3 has the int first and the string second. Remember, the return type that's out front here has nothing to do with a signature. So that should be ignored. Those words there should be ignored for the purposes of answering this question. Any questions? Moving on to number 8. Let's see, the answer there is C. You should be initializing properties in a constructor, and if not, if no constructors were typed out in a class, yes, Java will provide a free behind-the-scenes default constructor that automatically executes when you instantiate an object and sets all double properties equal to 0.0. Just saying. Number 9, the answer is A. Very similar to the worksheet question yesterday, so shouldn't be any real questions there. Number 10, E. Apparently E is false. No, it's just poorly worded. It's just a false kind of wording. You don't go around instantiating instance fields. The word instantiate has to do with objects. When you see in a client program the line of code bug Nemo equals new bug, somewhere in a public static void main string args, in a client program that is, this left-hand side is the act of declaring an object variable, and this right-hand side is the act of instantiating the corresponding object. You don't instantiate instance fields. Now true, within the bug, there might be a my age instance field, and there might be like a my health, and a my x, and a my y or something. But you're not instantiating those properties, those instance fields. You're instantiating the object as a whole. Within it, there are instance fields that are declared, but they're not instantiated. And don't even confuse that with the word initialize, because initialize means usually setting a variable equal to 0 or something. To instantiate an object means to find memory space in the computer, perhaps at a memory reference A32, and then that chunk of memory where my age and things like that can be set equal to 0, that's called instantiating an object. Moving on to number 11. We have our familiar bank account class, a very stripped down mini class here presented in a multiple choice question. So number 11, let's begin tracing this. This is tricky. Well, in the beginning, you execute the line of code B1 equals new bank account. So let's record that here on our scratch paper. B1 is a memory address of where in the memory of the computer the bank account has a my balance of 500. And let's pretend that the operating system comes up with a memory address A32. So an A32 here would kind of link or point to this chunk of memory. So that's the first line of code. The next line of code, B2. B2 is brought to life. It's a different chunk of memory because the word new is used. There's no aliasing taking place here. So a chunk of memory. Perhaps the memory address is B52, some hexadecimal number that the programmer actually doesn't know, but it doesn't really care because the compiler takes care of all this behind the scenes. And the balance for B2, well, let's check it out. We are calling the default constructor here because of these empty parentheses. We look up here at this class and we do find, unlike the previous worksheet, we do find a default constructor. We know that's the default constructor because it has empty parentheses, just like the call statement that I'm currently executing. So let's do what it tells us to do inside this default constructor. Oh, my balance equals 0. So B2, which is really the memory address B52 that points over here to this object, has a balance of 0. Phew, all that work just for 2 lines of code. But now we're set up to run the third line of code. We work from inside the parentheses outward, so we must first examine B2.getBalance. Well, luckily for us, there is a getBalance method available, and it returns a double, and specifically, it returns my balance. But whose balance does it return? Well, because we're executing b2.getBalance, because that's the call statement, we go to b2, which is b52, so we come over here to b52 and we find the balance is 0. So really, this is a 0 here inside these parentheses. That's a 0, because that's the 0 that was returned here as my balance, which plugged in here. And now we take that 0 and we send it as a parameter to B1's deposit method. Right here is the deposit method. We're passing this 0 up here, and it plugs in for the formal parameter amount, because we're calling deposit right now as a method, and here is that method. And the 0 plugs in here then and gets added to my balance. Well, this time, the my balance that we're talking about is B1's balance, because we're calling the deposit method from the perspective of B1, B1.deposit. And B1 over here in my scratch paper is A32, which means it's this $500 here that is really plugging in for this my balance at this moment. And 500 plus 0 simplifies to 500. And that 500 plugs into this variable new balance. And then a microsecond later, we're taking that new balance variable, 500, and we're overwriting my balance with it. Let's see, my balance, again, is this one right here. So we're crossing out a 500 and putting a 500 in there. What a moron. He goes to the bank, drives up to the ATM machine, and deposits an empty envelope. And the bank then kicks back a receipt that says, your balance is now $500, moron. You know, you've deposited 0, so you have the same balance. Well, anyway, computer software is dumb. It doesn't really call people morons. It just does what it's told, and if you deposit 0, you deposited 0. So this line, this third line of code works. It just doesn't really do anything interesting. Now the last line of code. B1.getBalance pulls out this 500, and we're depositing that 500, kind of the opposite of the previous line of code. We're depositing it into B2. So we're pretty much overwriting that 0 and putting a 500 in there if you took time to trace all this stuff up here like I did a second ago. So the moral of the story is, the answer here to number 11 is A. Both bank accounts, B1 and B2, have balances of $500. Turning the page of the worksheet, number 12, the answer is B. Both balances are 600 bucks. Let's just work through this one by waving our hands and not really tracing all the code. B3 has 500 bucks in it. B4 equals B3. So really, B3 and B4, they both point to the same object in the memory of the computer. So if the balance of that object is $500, like we've established in line number 1 there, really B4 and B3 both have 500 bucks. And then when you deposit $100 in the B4, and therefore it now has 600 bucks in there, you're really essentially depositing $100 into B3 also. It's the same account. So they both have $600 because they are both the same account. It's incorrect to say that there are 2 bank accounts. There's just 2 different names for the same underlying bank account is what you have. So the answer is B. Because this is called aliasing. And just trust me, there is a reason to do this in the real world, but right now you're just understanding that it's just makes for tricky AP style questions, and you'll be good at it with enough practice. Number 13. Let's see here. B3 is a bank account that has 500 bucks. Balance is 500. B4 is alias to B3. I don't really care what the memory address is because it really doesn't help me understand this any better. They both object variables point or reference, we say, the same underlying object. Okay, B3 is null. What that does, what null does, is it breaks this pointer. Whoops, my eraser was too fat. Sorry about that. The B3 pointed to this object, and so did B4. But the line of code B3 equals null sort of breaks. It breaks this link right here. So B3 is really equal to the memory address 0, or it's kind of like orphaned, it's isolated. It's not pointing to this object any longer. But B4 still points to that object. When you set one object variable equal to null, it does not affect any other aliased copies of that underlying object. So in the next line of code, when you do a get balance, which is 500 for B4, and then you deposit 500 back into B4, this is like doubling your money. It's not really legal, I guess, in a bank to walk up and just kind of photocopy your money and make it twice as large, the balance. But that's what happens in this code. So the answer to number 13 is C. B4 does end up having a balance of 1,000. Questions? Any questions again? Any questions in this? Robert!
If you were to set B3 to null, wouldn't that also set B4 to null?
Oh, good question. Question is, if you couldn't hear it, when you set B3 equal to null, doesn't that also set B4 equal to null? Well, no. Because here's the opposite situation. If you took B3 and deposited money into B3, that would indeed deposit money into B4 at the same time. When you change properties within an object, it does affect both aliased copies that point to that same object. But when you set one object variable equal to null, it breaks the link for only that one object, and we're not affecting individual properties within the object. So the link is broken, and Java garbage collects this object variable. No, I'm sorry, that's not, I'm sorry, I misspoke. That's not garbage collection. Garbage collection, I think I answered your question. Garbage collection is when, if you would set both B3 equal to null and B4 equal to null. In other words, if you break all of the links to an underlying object, Java is so smart while your program is running. Java is so smart that it realizes that there's an object to which no object variable points. And therefore, this is wasted space in the memory of the computer. And every so many seconds while a Java program runs, I believe, space like this is reclaimed by the operating system and then can be used by other programs. So that's called garbage collection. It was a topic, I think, in an earlier chapter. It's hard to explain, so hopefully you just learned what I meant by that. Java has garbage collection built into it, but a previous famous language known as C++ does not. With C++, even if you set a bunch of object variables equal to null, you still are wasting that space, and it slows down your overall computer unless a programmer manually, with a line of code, deletes and reallocates that memory for other purposes. It's kind of like if you moved out of your house because the bank foreclosed on you and nobody lives there, it'd be kind of like the house just being there for the rest of human existence. But garbage collection is kind of like the bulldozers coming and knocking down the house and letting somebody else build an object there and live there in a new house. Okay, real quickly here, number 14, the answer is C. B5 has a balance of $200. B6 is aliased to the same object as B5. B5 is null, so that kind of pointer there is broken, and now B6 has $100 deposited to it. So the code executes fine, there are no errors, and B6 does end up with a balance of 300. You can't really, and it's not really asking if what B5's balance, because B5 doesn't really exist anymore. Okay, the time class. The time class here, the answer to number 15 is A. There are no static methods, because do you see the word static anywhere? No. Number 16, the answer is B. This is, I remember a question in the previous worksheet where these statements were in the wrong opposite order. So this is the right way to implement a other constructor. So 16 is quite simply B.
That
Yes.
automatically stores 0 every time.
Yes.
So it goes from right to left.
Yeah. It goes from right to left. Assignment statements. Anytime you have something equals something in every computer language I've ever studied, the assignment operation goes from right to left. Hey, look at C. The parameters are in the wrong order. So that would be putting seconds where the hours should be and hours where the seconds should be. Just saying. Number 17, the answer is D as in dog. I don't have room on the to scroll down. I don't have time. So the answer there is D to number 17, and you can trace that on your own. Goodbye.